program. So the tagline for the overall success of energy conservation project or energy conservation assignment is being holistic. Means we cannot leave any single aspect. It's not that the 6 out of 10 is very good and then 2 of them are average and 1 is bad. So we can say that no, 6 were very good, so we'll get very good result. So that's not the case, right? In many of the cases, if we are average on all of them, right, even those kind of projects have given very good outcome. So that is why the message today I would like to give it to all of you is always be holistic. Don't leave a single aspect, right? Doesn't matter whether it is of comparatively lesser importance, so we'll see it later or we will address it later. It doesn't work like that. So we need to be holistic, because there could be 9 reasons for giving you savings, but there could be 1 reason for not getting the savings or failure of the project. So that 1 reason, right, will eat out all the 9 good points. So this is what the message I wanted to give it to all of you. So friends, basically our company is CTech Solutions, right? And we have also launched a small company that is a startup, that is Finefi Energy Solutions, that is for B2C customers. CTech is for B2B customers. So the 8 sessions were like this. First we saw how is importance of baseline and how that is carried out, and then how do we ideate for various energy conservation projects. Then how do we finalize project, because there would be multiple projects and every project would mean rupees invested versus rupees saved. Normally what happens is all techies get hooked on to one particular idea or one particular project, and then try to see that how whether that is feasible or not feasible, and if that is feasible, then they go ahead with the implementation of that. However, any project is ultimately rupees invested versus rupees saved, right? So all the projects actually compete with each other, right? So that is why we strongly suggest that the moment we get one project idea, right, it's not that we have to just go ahead with implementation of that. Let us at least pick up a good number of ideas and then find out which one is better and which one should be given earlier priority. So that is what we cover in finalization of project. Then what happens is the project has to be financed either by the company or by the ESCO or by the bank, right, or through any other third party, or whichever way it is possible. But without financing, energy efficient project cannot be implemented. So this is very important. Then once the financing part is over, then the procurement, right? And procurement doesn't mean purchase only. There are so many things which play a very important role in procurement of energy conservation project, because the purpose of procurement is not to just procure those energy efficient devices or energy efficient equipment. Procurement has to result into actual savings. So that's the importance of it, right? Having done the procurement, then there comes implementation. And after the implementation, we have to actually do monitoring and verification of all the key parameters, right? Whether we are getting the savings or we are not getting the savings, how much savings we are getting, right? If we are getting more savings, what are the reasons? If we are getting less savings, what is the reason, right? So there has to be a continuous monitoring, right? Then operation and maintenance of energy saving project is equally important, right? Because once achieved, the savings should be continued for a long duration, right? So what is our strategy for that? So that comes here, right? And then the 8th one, which is today, that is summary of every learning from 1 to 7, and we are going to discuss that in a holistic way, right? In individual sessions we spoke about the importance of individual things, right? But today we are going to talk about all of them together. And learning, believe me friends, even after having successfully delivered so many energy conservation projects even on energy performance contracting basis, the learning never stops. So learning is actually key to the success of energy conservation projects. So the baselining, that was our very first session, right? So baseline is the present energy consumption scenario, right? What is the present specific energy consumption, or what is the total energy consumption on a daily basis or a per unit of production basis, right? So how do you fix this, right? Because you will require 2 numbers. one number is before your project and one number is after your project, and difference of these two numbers is actually the contribution of any energy saving project. It's not the physical look of an energy saving project, right? Whether how good it looks like. No, what is the impact, what is the financial impact of an energy conservation project, that is important. And that is that the very first thing that is needed is accepting that what is the present energy consumption, right? And if there is an impact of production on that, if there is an impact of occupancy on that, so all these aspects needs to be detailed out, right? However, it can be very complex, but what we have seen over a period of time is that keeping it simple works, because every stakeholder has to understand it, right? It's not that the ESCO has detailed out a very good, very comprehensive plan to quantify the savings, but it becomes so complex that it cannot be understood, right, by the other stakeholders, so it doesn't work. And that is why we say that transparency from every side is very important, be it the customer, be it the ESCO, or be it the OEM, right? So the moment you arrive at right baselining, that means that, for example, in case of a hotel, if you say that the energy consumption is this much units per year per room, right? So that number is immediately gives you a reflex idea whether more savings are there, or whether whether the unit is running really well, right? So this baseline number is the key. It gives you everything, right? And then we have to always remember that energy saving is a long-term phenomenon, right? It's not that it is just one-time kind of a thing. So we need to maintain the project very, very properly, right? So this was the baseline and actual project cost, right? So green one is the baseline, and the blue one is the energy cost after implementation of the project. So the difference of that is a clear-cut savings month on month, right? So how do you define the baseline? Suppose if you do a mistake in defining the baseline, and that is signed in a contract, right? But then that mistake has happened forever, right? So that is why we have to be very, very careful in defining the baseline, because every time, whatever may be the energy conservation project, you are going to actually refer back to this baseline, right? Because before implementation of the project, what was the energy consumption? Okay, so what is the learning is expectation from energy efficiency is always a difference between two numbers, right? So which are these two numbers? The first one is the baseline, I mean, before implementation of the project, and second is the outcome of your ideation. Outcome of your ideation means how are you going to save the energy cost or energy consumption, right? And it is not just the idea, right? But after the implementation, what would be the number that will come up? So this difference between these two numbers is your key to overall saving project. So from that point of view, baselining is the first right step to do any energy conservation project, right? Now, having done the baseline, right, this is the specific energy consumption at present, or this is the daily energy consumption at present, right? Now I want to reduce that, right? Now for reducing, there could be number of ideas, right? So that doesn't mean that each one of them has to be taken for implementation, right? So like a good doctor, right, we have to really do a very good pathology and then come up with all possible ideas for energy saving, right? And then finally choose a few, right? Because doctor doesn't give us or prescribes us all the medicines which are available in the medicine shop. Like for example, the number of energy conservation technologies are also as high as number of medicines available in the medical shop, but then we don't need all of them. Like a good doctor, a few number of energy conservation project will give you the resultant savings what you are expecting, right? So ideation, we strongly suggest that it has to begin with the baseline and not with a preconceived mind that no, I have seen this idea or I have seen this project there, so we will also do this project here. No, not like that, right? And then diagnose first, right? If this is the baseline, then why is that this is the baseline, whether good or bad? So that is what I very clearly emphasize, that diagnosis is the first thing. And the moment you reach to the diagnosis, right diagnosis, you will clearly come up with the loss points. Like why is that the losses are happening and how much the losses are happening. The moment you get this, right, then you very systematically you reach to the ideas which are really going to give you a good amount of energy savings, right? Because you have gone through it systematically, you have gone through it as a process, right? So And also remember always, like for example, if you get one idea and if you implement that, right? But then what happens is with implementation of every idea, your baseline is now improving. You do not have the previous baseline. So suppose if there is a better payback project which is possible, right? But now since the baseline is reduced, right, that good payback period project also will not be possible, right? So we cannot afford to do any mistake here, right? However, mistakes still happen, right? So always keep a margins, right, for delivering the claim savings, right? So usually what happens is, let's say if we have tried or if we have planned to go for 20% savings and we see that 20% saving is possible with 6 projects, as a factor of safety, we would always prefer to implement 2 more projects. And we would always prefer to go for conservative estimate of the savings, because after implementation of the project in the measurement and verification, we should be getting right savings or the claim savings, right? So let the ideas be as many as possible and let us consider all of them. Let's not drop that anyone at the idea stage. But when you are finalizing them, right, at that point of time, you have to pick up those few ones, right? Now, that picking up those few ones comes here, which is project finalization, right? I mean, which are all those ideas you are actually going to take up for implementation of project, right? So we again strongly suggest that project finalization should again be based on overall diagnosis, right? So automatically we get better priority project, better ROI project, right? If we are hooked on to one particular idea, then we are behind implementation of that particular idea, right? And we may miss on the better ROI ideas, right? So this project finalization step is as important as that doctor has done the diagnosis and doctor is now writing this prescription, right? So doctor has to be absolutely right in coming up with the prescription, right? And his prescription is an outcome of the overall process, whatever is the touch point, right? In terms of patient's condition, patient's pathology report, and whatever is the conclusion, and then comes the treatment. So similar is this process as well, right? And friends, again, I will say that every energy conservation project is finally rupee invested versus rupee saved, right? Or rupee invested versus a given quantity of GHG emission saved, right? So all projects compete with everyone, right? Let's not say that this is this particular project or this is this particular technology, right? End of the day, if we are implementing an energy saving project, then it is very important that we do justice with all the possible ideas, right? And then only finalize it, right? So if we choose the second or third best, right, then the feasibility for the best one is gone, right? Because your baseline doesn't remain the same, right? Because you will definitely be getting some savings, right? So the best idea project in that particular situation, it is very much possible that that would become non-feasible, right? And that is the reason we have to do it very, very carefully, right? And then what happens is every energy saving project, right, will give you some saving, right? But how do you calculate cumulative saving? Like for example, when simplest of the project like LED project, if it is implemented, it is very easy to quantify the total savings, right? But then what happens is because of the LED project, there is a reduction in the heat load, right? Which is now not happening. So how much will be the savings on the chiller side, right? So this becomes very, very key issue, right? And that is the reason, because finally it is not important that this particular project is giving how much saving or that particular project is giving how much saving. Cumulative, are we able to see a lesser energy cost, right? Cumulatively, are we able to see the reduction in energy cost in the electricity bill or in the fuel bill? Then and only then a right conviction comes. Like for this much level of production or this much level of occupancy, our energy cost or our energy consumption was this much. Now with the same level of occupancy or same level of production, we are getting a lesser cost, right? And this kind of inputs coming from the finance side or this kind of input coming from the management side is the key, right? Not that the glorifying the project just through the pictures or just through the description or just through the reports, not like that. So every project, right, is going to give you energy cost savings. And all those savings in energy cost are ultimately measurable in terms of rupees, right? So that is the reason why every energy conservation project finally turns out and goes through the same funnel, right? So the message here was there are plenty of medicines in the medical. Now, once the project finalization is done, right, then comes the financing, right? Now, there are so many methods of financing. Normally, what happens is in some of the cases, the budget is available, some of the cases, budget is not available, right? Some of the cases, ESCOs would invest, some of the cases, banks would invest, right? So there could be so many things, right? But end of the day, it's ESCO's job to facilitate financing, right? ESCOs may opt to do it themselves, or ESCO may get the financing from outside for the customer, right? But ESCO's presence is absolutely necessary. Yeah. So what happens is financing aspect normally is not given that much of weightage or that much of priority by the energy conservation professionals, because that becomes a financing subject, right? But it doesn't work out like that. We have to give due weightage to that, because if the budget is not there, or if the financing options are not there, the project will never happen, right? So we cannot say that our job is only technical, right? We have to come up with ways and means for financing of the project, right? So what we believe in, what we are doing these days is, right, we are actually coming up with EMI or lease rental, right, which is less than the savings, right? So usually our lease rental or our EMI, right, are coming out to be 75% of total savings. So 25% is the positive cash flow for our customers. So that's how we are doing it, right? Because and doesn't matter what not level of technical sophisticacy any project might have, but end of the day, every energy conservation project has to clearly give measurable reduction in the energy cost, right? Because that's the ultimate purpose of an energy saving project, right? And if it is not delivering that, then what happens is, even in that situation, energy conservation project would be celebrated, would be shared, but the drive for the energy conservation or the priority for the energy conservation doesn't come then from the top, right? Because it may look like that fine, it's an energy conservation project, but it's not contributing to the profitability. Whereas a good energy conservation project contributes to the profitability in much better way than several other ways of it, right? And then the savings need to be maintained over a period of time. That is also equally important, right? And the role of OEM is very important here, right? And as course, normally they prefer those technologies wherein they are comfortable with the OEMs, right? Because we cannot say that this a particular ideas, but then we cannot get the OEM here because we are not in touch with OEM. No, we have to procure the project, right? So procuring the project will never happen unless until there is a good relationship with the OEMs, right? And if we are able to give a positive net positive cash flow, right, which we are delivering it for our customers, right, there is no need for a separate budget for the customer, right? So normally what happens is the customer's appetite for energy saving project is limited, right? If I share with you frankly, normally energy conservation projects are being used as a KRA aspects by plant engineering people, and then every year some of the energy conservation project is getting implemented. It's fine if it is at a KRA level, right? But at a plant level, are we able to see the resultant reduction in the energy cost? Is that reduction clearly seen in the monthly paid amount towards energy cost, right? Because that is the potential energy conservation projects have, right? And that is what has to be targeted, and that is what has to be achieved, right? So in this manner, wherein the lease rental or the EMI, right, is 75% of the savings, right, clearly a net positive cash flow is given to the customer. Then the procurement, right? Then the procurement. Now here what happens is procurement normally considered as a purchase, right? But this is much more than the purchase activity, right? We always prefer to do a life cycle costing, right? Because life cycle costing means putting together what is the capital cost and what is the operating cost, right? Because every energy conservation project, if we implement, right, let's say if it is a utility and we are trying to select a utility which is going to give us a lesser operating cost, right? But that utility will cost more, right? So with L1 procurement, right, energy conservation projects or energy conservation procurement or energy efficient procurement can never be done. So it has to be done with a life cycle costing approach, right? And we have seen here that when ESCOs identify the project, the resultant guaranteed savings or resultant measurable savings are definitely there, right? And herein what happens is ESCOs implement the project like a turnkey contractor, right? But in that contract, given a level of energy consumption or energy efficiency or energy saving is clearly defined in the contract, because ultimate purpose of the project implementation is not the project itself, but the outcome or the savings from that project, right? Then obviously the finance has to be facilitated by ESCO. We discussed it earlier, right? And it is key. Without financing, a project would never happen, right? Then the procurement ensures this particular aspect also, that the monthly lease rental or EMI, right, is lesser than the savings. So what is happening is the EMI or the lease rental is actually getting paid through the month actual energy cost which has been saved, right? And that is how positive cash flow is delivered, right? And savings are maintained. So a procurement would mean all of them, right? So friends, having done this, please do put your all the questions, all the thoughts in the question portion of it. As the program is completed, as my presentation of these slides are completed, we will be taking them, right? So even at the implementation level also, we have to think in totality. We just can't think in terms of how the erection will happen, right? That's why we don't call it as erection, we call it as implementation, right? So again, at this level also, we have to get back and see that what was the baseline that was decided, right? Because at this level, if at all any change is to be done, you can take it, right? Because once the project is implemented, that means that the investment has been done, right? So this is the final step at which you once again review all your investments into energy efficiency project, right? It's not that the fundamental thought was given at that point of time, right? Because let's say if it is 1 or 2 months earlier, or even in some cases 3 months earlier, a lot of changes happens, a lot of new technologies also keep coming in, right? So we have to ensure that we have considered and evaluated every one of that, right? So what were the ideas, right? How the projects were finalized, right? How the finance was obtained for this, right? How the procurement was carried out, right? And during the implementation itself, whether the monitoring plan is being put in place or not, or otherwise what will happen is we have implemented the project, the idea was good, the saving calculations were accepted by everyone, right? But we have not clearly defined the baseline, right? So once we have not defined the baseline, it's impossible to come to the baseline energy consumption figures once the project is implemented, because now your energy consumption is completely different, right? You cannot say that your previous energy consumption was this much, right, if that proper baselining has not been done, right? And what is going to be the monitoring plan, right? We have implemented the project so nice and we know that there are savings, right? But we have not decided the touch points on which we are going to monitor it, right? So later on it cannot be done, right? Because that kind of metering has not been planned, right, in the project. Then it becomes additional cost. Otherwise, in the project itself, the energy monitoring appliances or devices, right, gets covered, right? And we have always seen that the moment you do 1 to 7, you definitely come up with some corrective actions. And that is the reason the implementation process at this stage, we very strongly suggest that let's review, right? And it happens that there are some failures, right? And we need to understand that is a part of it, right? Because it's not a fixed bill of material procurement and bill of material procurement, right? Or it is not just making a production out of it, right? It's basically that the difference in two numbers is what we are talking right since the beginning, right? So this is the final point at which we have to evaluate everything once again, right? And that is the reason why ESCOs have been comparatively more successful in delivering energy cost savings, because they have been doing all these kind of things in a very, very methodical manner. So friends, having implemented, let's see what now. The implementation of the project is not just that physical implementation of the energy conservation idea. The purpose was that I should be getting clearly measurable savings. And what is saving? What is my baseline and what is my current energy consumption? So difference between these two numbers, right? And whether that difference is coming as per the projected number of energy savings, right? If we are getting that savings, right, then and only then it is meaningful. Friends, I would like to share one actual case, right, with one of our customers. When we were making the proposal, right, the team came up with a saving potential of 19%, right? And we said, why 19? We can always make it 20. We have done it 20 so many places, right? But team said very clearly, nahi aayega. We will not be getting 20, right? And believe me, friends, the project was almost 5 years, right? And after completion of the 5 years, right, the actual savings were 19.5%, right? So that's the beauty of your energy understanding of the energy conservation as a subject, understanding of different technologies, understanding of actual energy savings that can be obtained by implementing different ideas, understanding of how different ideas, when they are implemented together, and what is the impact level, right? So that learning primarily comes when you very meticulously monitor what is the daily energy consumption, and then at monthly level how it is going on, and not only energy consumption but all other parameters, right? At which because energy consumption is again an outcome, right? If you are improving condenser performance, then chiller saturation temperature will reduce. It has to reduce, right? So are we getting all these parameters as projected? If we are getting these parameters as projected, obviously we will get that much of savings, right? Because if the projected operating parameter is what we have to achieve, and that is what we target at, right? And if we do that right, the energy saving has to happen, right? It's not that the difference in two number is right, so we are all happy about it, right? Because if your savings are coming more, or if your savings are coming less, and you are not able to identify why it is more or why it is less, so again that is a technical lacuna, right? And this would cause problem later on, right? Because if you have understood that why you are getting more savings, then you will obviously alter your saving calculation approach for your next projects, whether it is more or whether it is less, right? So IPMVP is an international guideline, right, for doing monitoring and verification of the savings. So that's what is applicable worldwide, and we also follow the same, right? But we monitor performance of overall energy conservation equipment. We always believe in, if a project size is of a particular value, then we also man all the sites, right? Because having implemented an energy saving project, having demonstrated the savings, many times it happens that understanding of that particular technology, it does not start that fast with the unit, right? And something is not maintained properly, or not operated properly on a day-to-day basis, then actual savings will get hampered, right? And that is the reason it is very important, right? And something will go wrong still, right? So we need to take corrective actions. So a good M&V very clearly tells us that what additional things are to be done, right? In one particular project, again, I'll share one example, that we were doing monitoring and verification very closely, right? Then the monitoring and verification team was different than the project team. Now, this team came up with more ideas, that fine, we are getting savings, right? And we are getting the projected savings, right? So it's actually a reason for everybody to be happy about it, right? But the monitoring was also being done for all the performance parameters. So performance parameters, when you are monitoring it, right, apart from the actual savings, you also come to know that there is still more saving possible, right? And then we also concluded that these more savings, right, can also come up very fast. So when you do a good M&V, right, you always come to know that how you can enhance the savings, right? And a good M&V will give you a trigger much earlier that a failure is happening, right? So how are you going to handle those failures? So that also you come to know, right? So summarizing the whole implementation approach, right? So what do you do, right? A good energy saving project or a good idea, or somebody has implemented it successfully and then we are trying to implement it at ourselves? No. What do we do first? First thing is to be done. Am I targeting 5% savings, 10% savings, 20, 30, right? Up to 30% savings in commercial building and in industrial utilities is what we have seen is achievable, right? Because if this number is not fixed, your ideation will not go proper, right? Because if your number is smaller, definitely you would try to achieve it by improving your operating condition or by making comparatively very less investment, right? We strongly recommend that the units should identify their partners, right? Because this journey is not easy, right? And when you're targeting to achieve something like 10% or 20% savings, right, or 25% savings, right, then definitely it's very, very comprehensive job, right? So all the energy saving projects, right, should be identified with the savings, with the investment, and also with the ROI. And it's also always important to compare them on these three parameters basis. The moment you compare them, right, and you see a holistic picture, you come to know that what are all those projects need to be finally chosen, right? And finally, who is belling the cat? I mean, who is finally saying that this much of savings will be there from this particular project, and I am responsible for this, right? So we suggest that team, right, or that person needs to be actually driving all the project, right? And we have also seen that when energy conservation project goes through normal purchase routine, right, it's very difficult to implement the project with its full potential, right? We have seen some of the energy conservation projects actually getting ruined just because of following the particular purchase procedure. So that these are all those reasons why some of the energy conservation projects remain idea, right? They are not easily implementable, right? Then monitoring the progress, measuring the savings, measuring the parameters is key, right? It happens exactly like a admitted patient in a hospital, right? His temperature will be monitored, his BP will be monitored on a regular basis, right? And doctor, when it comes on a morning or a evening round, then they will have a comprehensive look on all the parameters and will again recommend the corrective measures, right? So exactly it works out the same way in any energy conservation project, right? And then the communication is very important. We have to communicate, right? What is the progress, whether savings are coming or not coming, right? If they are coming, then what is the learning out of it? If they are not coming, then what is the learning out of it? So this communication is also a very important parameter of the energy saving project, right? Because what happens is the moment one successful energy conservation project is done or two energy conservation project is done, there is a normal acceptance that picks up in a particular unit, right? And definitely the environment for implementing energy conservation project improves a lot, right? Earlier, there was a thought process like if a plant or if a unit has not implemented energy saving project, then there is more saving potential. I agree there is more saving potential, but at the same time, there is more resistance as well, right? Now, what happens is there is a plant which has implemented several energy conservation projects, and now the uh, acceptance level is very high, but actual energy saving projects or ideas which are left to be implemented are very less. Friends, believe me, we prefer the second one, wherein the saving potential might be less, right? But the readiness to implement an energy conservation project is very, very important. So this was the last session, right? And in last session, we said one point very clearly that what should be the philosophy of operating and maintenance of an energy saving project, right? And therein we said that it has to be a performance-based measurement, performance-based operations and maintenance of the energy saving project, right? Because project was anyway running, right? If there was an older compressed air system, it was giving compressed air. The point was it was consuming more energy, right? And new one is also delivering compressed air properly, right? But that's not the purpose, right? We should be able to get a reduction in input energy consumption at a compressor level, right? So that is why if you are monitoring the performance, right, and if there is a reduction in the performance, right, at that point itself, the O&M strategy has to speak out, has to take up actions, right? So that is the reason goals of operation and maintenance of energy saving project are something more, or there is a definite additionality as compared to normal operation and maintenance of plant equipment, right? And that is why we say that the consistency is what matters. Earlier thought process was a breakdown maintenance, then was predictive maintenance. But with the energy conservation project, it has to be a performance-based maintenance. Right? So this is what we had learned in the previous session, right? So this is something very, very important. And now when you are going to take performance-based maintenance initiative of energy conservation project, you should be able to monitor the performance, right? And if the performance is getting down, then what is the reason? I mean, we can very clearly say that yes, it's going down now. We are not getting that much of savings, but it is just a number, right? This number doesn't giving you idea, right? But if you are doing performance evaluation on all the performance parameters, right, then you would certainly come to know that this particular aspect is getting on a wrong direction, and you can take a corrective action, right? So similarly, goals of operation and maintenance of a good energy saving project, right? It has to protect the equipment and maintain savings. It has to improve the efficiency. Obviously, it has to improve the performance, but performance and efficiency both are interrelated, but at the same time, both are different parameters and clearly measurable in two different performance and efficiency level parameters, right? So awareness and accountability, these two things go hand in hand, and we very strongly suggest that because if you improve the awareness, there would be more inflow of energy saving project, right? And if there is accountability with it, right, then what happens is the reality in reality the savings also improve, right? And obviously this also results into reduction in downtime and failures of energy saving project, which is very important, right? So it's a very important aspect in quality and life of energy saving project. And that is why O&M goals are much more than normal O&M goals of any plant machinery. So friends, these are the examples of net positive cash flow, which is possible for any energy conservation technology, right? We can do that, right? So what is happening? Because of implementation of this particular project, right, there is a net saving of 1.9 lakh, right, on a monthly basis, right? Then similarly, there is another project, right, which is evaporative condenser. So any technology has to be finally fit in into financial numbers. So this is something very, very important, right? Same way, there was a third project in air conditioning level, right? But in all these projects, what has been done is the monthly EMI or the lease rental, right, is significantly lesser than the actual energy saving, right? Then we would like to share with some of our programs. So we have come up with an energy efficient motor program. Here we have been able to come up and deliver phenomenal savings, that is with I4 and I5 motors, right? So these are the new technologies and they are giving very good savings, right? So in this picture, you can actually save a large motor is replaced by a smaller motor, right? And this is basically I4 motor and it is giving a very good level of savings, right? In some of these motors, we have received very, very good saving, right? So here you see a saving of around 23%, right? And the payback period for an energy efficient motor is less than 18 months, which is 1.5 years, right? And these are all measurable, clearly measurable. And that's why we have been able to deliver these savings on a guaranteed basis, right? Another project, right, the I5 motors, right, here the projects are giving much better savings. So we were quite surprised to see 45% savings in this case, right? I'm not saying that this kind of savings will come up with every I5 motor, right, but definitely our projects are delivering 10 to 15% savings in energy efficient motor projects, which is a very, very good number. And what we have seen is that all the motors will not give this much of savings, right? But a 25% to 40% of the motors will surely give a very good amount of saving. right? Our other programs are actually energy efficient fans, blowers, right, which we are able to achieve through EC fans and plug fans, right? Then in HVAC we have four technologies, right? A combination of that is giving very good saving, right? And then recently we have added high temperature heat pump, right, in the range of 80 degree to 110 degree, right? So friend, this is the actual case wherein the green line is the baseline, and the blue line and maroon line are actual energy cost after implementation of the project. So you can see that very, very consistent savings have been achieved. And these kind of consistent savings are an outcome of a well implemented, well planned energy saving project on all these parameters which we have just discussed, right? So energy saving project is much beyond the idea, much beyond the project how it looks like, right? And it has to deliver its ultimate purpose, that is getting actual savings on a consistent basis. There are so many energy saving projects and so many energy saving technologies, right? And numerous. Again, I'll say that nothing like this technology is good or that technology is good. There are umpteen number of technologies, and all depends on what kind of technology is applicable to what kind of a scenario, right? And that is why the selection of energy conservation project becomes very, very important, and that has to be done methodology wise and not just on the basis of that feel. Right? So these are some of the projects, some of the success stories, right? On the left hand side, you see the energy savings achieved in a commercial building kind of scenario, right? And on the right hand side, you see in a manufacturing setup. And these are on the center table, right? There are so many energy conservation technologies which have been implemented and their respective savings. In this range, we have achieved them. So friends, to simplify all this process, right, we have made our model and we have given it a framework, right? And the name of the framework is cost. Cost, first one is the cost analysis, means we try to understand that how energy cost is happening at different process levels, at different levels, at different stages, right? Then once the costs are known, then we see the evaluation, like how these costs can be brought down, what are all those means and options which are there, right? And then we optimize them, right? And then we select them. But after doing everything, there has to be net savings which are available, right? And we name them as transfer the savings, right? Because purpose of any energy saving project is to physically achieve actual and real savings. And unless and until this is not done, right, the respect for energy conservation projects doesn't come, right? And that is the reason why this complete holistic and very thoughtful approach is important. It sounds a lot that we are able, we are, when we are putting so much of effort, right? So we will not be able to do more and number of energy conservation projects. We might get stuck up with one saving project. No, actually what happens is if you are methodical, you can actually implement so many number of energy saving projects, because it is the methodology which is ensuring the outcome and not the individuals. Thank you. So we will take the questions now. Kunal?
Yes.
Let's take the questions.
Sure. So the first question is regarding the M&V.
Yeah,
In absence of a past data, how to formulate the correct M&V?
very good question, and this usually happens. And now, particularly after the COVID, right, there is no past data. There is absolutely no past data, right? So how do you do that, right? So now, what we have been doing in some of the cases is that we do it at an equipment level, right? At equipment level, how the things are, right? At different loading, how the things are, right? So baselining is done at different loading levels, right? Because right now there is winter, right? But if the summer is coming up, then how do you do it? Or let us go back to the earlier time when there was consistency, right, in the baseline, right? So it has to be very, very careful decision of what is to be done, right? Or for example, there are projects like LED project or energy efficient motor project, right? Here you can easily do it with before and after measurement. That's it, right? So there is no impact of savings on the things when you are implementing these two particular kind of projects. So that is why, and this is the real key point in implementing and achieving success in an energy saving project. Yeah, Kunal, next one.
Yeah. So next is what are the financing options available for the energy efficiency projects?
Friends, believe me, banks' business is to lend money. If nobody takes money, banks are not going to be in business, right? We are just technocrats and we get exhausted in dealing with banks. That should not be the case, right? Banks would lend if there is a good projects, if there is a good customer, if there is a good ESCO, right? Money will flow in. Money is never a problem to a good project, to a good client, to a good ESCO, right? But what happens is we do not put that much of level of efforts, right, in terms of getting the finance, and that's the problem. So number of options are plenty. We ourselves achieved without collateral, right, from Tata Cleantech, and not for 1, 2, or 3 projects, for more than 10 projects, right?
Yeah.
Yes, Kunal.
So yeah, the next question is what is this? Your energy efficiency program details?
So in this energy efficiency program, what happens is let's say you join our energy efficient motors program, right? So what we will do is, right, we have a platform. That platform actually maintains the database of motors, right? So we will take your one of the section, or you will take one of your section, and you will put that data into the platform, right? We will analyze that data, right, and we will come up with energy saving projects option only with energy efficient motor in that program, right? And then we will guarantee you that this much is the saving, right? And if that much of claimed savings are not there, then we will refund your money and we will take back the motor. So you would always be getting the claim savings, right? And if you need financing, right, so we will get that financing also for you, wherein the EMI, right, or the lease rental will be 75% of the actual saving. So straightway you get 25% reduction in terms of energy cost on that particular motor. Yes.
So the next question is how much should be the M&V cost in any project? Is there any benchmark or thumb rule?
See, normally people say 5%, right? But see, it is actually need based, right? Like for example, in an energy efficient motor program, right, what we will do is we will measure the power consumption before implementation of the project. We have done it earlier also, right? But at that point of time, how much is the power consumption just before implementation? So we will again redo it, right? And we will again install the energy efficient motor and we will again measure it, right? So this kind of M&V, right, will not be having any significant cost, right? Whereas I am trying to demonstrate energy saving on the overall energy bill, right? So what is the month-on-month baseline, right? And then how is that I'm going to measure that actual ongoing energy consumption and actually quantify ongoing energy cost, right? So this will have a very methodical approach to M&B. So this will have a lot of cost. So it all depends on what kind of project you are choosing and how is your M&B plan. So your M&B plan is actually going to decide your M&B cost. And we decide to a particular M&B plan completely based on what is the project. Yes.
Yeah. Thanks, Melissa. That's all the questions, sir.
Okay.
Thank you.
So friends, thank you all, right? So we had 8 sessions. I hope that there was something to be taken from them, right? And I'm very sure you would have got benefit. And if you are looking forward to these savings or join our program, right, do write to us, right? And let me ensure you that you will definitely get good benefits out of it. And please remain in touch. Thank you. Thank you very much. Bye.